Good morning today. Yesterday, the topic of sphere was half left. We have read about its we have read about its surface area. Now, today we'll learn what will be the volume of a sphere. In this session, we will discuss how the formula of volume of sphere has been derived. Okay. Surface area we have discussed yesterday. Now, today we will learn how the formula of volume of a sphere has been derived. Many of you know the formula of volume of sphere because this formula you have read in class 9. So before starting the topic volume, I just want to know what is the formula volume of a sphere. Please reply me fast. I had told you that instead of writing good morning and all this, it's better to write your reply. My question is, what is the formula volume of sphere? I'm just waiting for your reply because this is previous knowledge. The knowledge about the volume of sphere you should already know. Because it is a part of your previous knowledge. I just want to know what is the formula of volume of sphere. Without taking time, I just want to recall you 4 upon 3 pi r cube. This is the formula of volume of sphere. Many of you know already because this has been taught to you in class 9. So volume of sphere is 4 by 3 pi r cube. Now, my aim is how this formula has been derived. Okay. Yesterday I told you about the equivalent figure. I again took a sphere and a cylinder with same radius and same height. Got it? The radius of this sphere is or small r same. The radius of this cylinder is small r. Now, height of sphere and cylinder is same. That's why they are called equivalent figure. Clear? Now we have taken equivalent figure. One is sphere, another is cylinder. Both are having same edges, meaning same height, same radius here. So, through the lab activity, again we will discuss because this can be proved or verified only through the lab activity and through an activity. Okay? Well done, Kushi Joshi has replied the formula volume. Okay, nice data. Because I know many of you know the formula volume. I just want to recall how this formula has come. This is my motto, my aim. Now, I have taken the equivalent figure. Okay. Now what happens? Through an activity, it has been proved. Through an activity, it has been proved. Sorry for interruption. I just want to again recall which figure has greater value. Yesterday I told you about this. Both are equivalent figures. I just want to know which figure has greater volume. Out of these two figures, Which one has greater volume? Reply me fast. Which figure has greater volume? Beta, okay, good morning, okay, but reply me. Which figure do you think has greater volume? A sphere, both are equivalent figures. So out of these two, which has greater volume? Kamaljeet has replied cylinder. Kamaljeet replied cylinder. I just want to know many more answers. Khushi again has replied cylinder. Beta, reply. I just want to know your opinion. Only I am thinking that will be monotonous. Your reply is necessary. Out of these equivalent figures, cylinder has greater volume. Okay. Why? You can see middle portion almost has same volume. But you can see upper portion and lower portion. In the case of sphere has less volume. Upper portion, this is missing. This space is missing in sphere. If you look clearly, this space from the upper and this space from the downward. So this space, since this space is missing in the sphere, that's why sphere has less volume compared to equivalent cylindrical cylinder volume. Clear? Because this space is absent in the case of sphere. Got my point? So, I am clear that out of these two, sphere has less volume. Out of these two, sphere has less volume. Clear? Because beta, for finding the volume, this should be computed. Sphere has less volume compared to cylinder. So now, what is lab activity? Lab activity is that when we take 3 volume of sphere, it will equal to the 2 volume of cylinder. This has been proved in the lab activity. But what is that? 3 volume of sphere will be equal to the 2 volume of cylinder, because cylinder has greater volume compared to sphere. So sphere needs more times compared to cylinder. Suppose the lab activity is like this. We have taken sand and fill the sphere. Now pour it in a space. Pour it in a cylinder. Similarly, when you fill 3 times the sphere, it will fill 2 cylindrical vessels. I repeat, the lab activity is there. Suppose we have 2 cylinders. 3 times of this sphere, sand will fill 2 cylindrical vessels. So proof is that volume of 3 times volume of 3 sphere is equal to volume of two cylinders. Because cylinder has greater volume. I told you earlier. So lab activity proved that three volume of three spheres it will be equal to the volume of two cylinders. Clear? So 3 into volume of a sphere of sphere. 3 into volume of sphere. Now volume of cylinder, you know already. Here we have to take two volume of cylinder. So volume of cylinder is pi r square s. You know. Pi r square. This is the volume of one cylinder. But we have to take two cylinders, so twice of volume of one cylinder. Clear? Now, look at here. I told you height of the sphere and height of the cylinder is same. So height of the sphere is diameter. Diameter means twice of r. So h will be equal. This h will be equal to the diameter of the sphere, and diameter of the sphere is twice of radius. So height of the cylinder will be equal to the diameter of sphere, and that will be equal to twice of r. R is radius. So in place of twice of volume of sphere, two as it is 2 pi r square as it is. In place of h, we will take twice of radius. So now find the volume of one sphere. Volume of one sphere. Find the volume of one sphere. First multiply here 2 to the 4 pi r square into r will give you r cube. R square and r will give you r cube. So 4 pi r square on the right side. Now 4 pi r square is the volume of 3 sphere. But here we have to find the volume of one sphere. So 3 in multiplication here comes as divide on the right side. Because beta 4 by r cube is the volume of 3 sphere, but we have to find the volume of one sphere, so 3 comes in division. Okay. So we got the formula of volume of sphere 4 by 3 pi r cube. I hope you have come to know how the formula has been derived. Sorry. 4 by 3 pi r cube. Clear? So that's how the formula of 4 by 3 pi r cube, that is volume of the sphere, has been derived. So the basic concept is that volume of 3 sphere will be equal to the volume of 2 equivalent cylinders. Then we will solve it. Okay. Now coming to next topic, hemisphere. 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 But the proof of CSA cone, CSA of cone, and surface area of cylinder, surface area of sphere, volume of sphere, all are your lab activity. So your lab activity simultaneously being completed. Clear? Well, all these comes in your lab activity. So next is hemisphere. 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 Some students confused with semisphere. Semisphere is not correct because semicircle is used, but not it is used in sphere. In the case of sphere, semisphere is not a word. Hemisphere is the word. Okay. Half of the sphere is hemisphere. Half of the sphere is called hemisphere, just like bowl. Bowl, but when we talk about 3D shape, immediately imagine their shape. In the case of hemisphere, sorry, examples. I just want to know the examples of hemisphere. Because this has been taught to you in class 9. Nobody is unknown to this topic of hemisphere. So first I just want to know the example of hemisphere. Reply me fast. Examples of hemisphere. Before moving to the topic hemisphere, I just want to check your previous knowledge about hemisphere. So give me the example of hemisphere. Anmol, okay, your reply is bowl, but unknowingly, this example has been given to you by me. I just want your example, your own example. Hemisphere. Beta, bowl, okay. Many more examples. ऐसा नहीं कि आप इंग्लिश में रिप्लाई दें, आप हिंदी में भी रिप्लाई दे सकते हैं, हिंदी के भी। सपोज आपको कोई वर्ड हिंदी में आ रहा है, इंग्लिश में नहीं बता पा रहे हैं, यू कैन रिप्लाई इन सिंपल हिंदी। But only bowl is in hemisphere. Only bowl is hemisphere. Very nice example. Khushi Joshi has given some another example. A cut piece of onion. Yes. This is the example. Many natural things you can find near about you that are in hemispherical shape. Tomato. Okay. Yes. If we have the orange, actually orange is not exactly in sphere, but almost we can assume it in spherical shape. When we break the orange, we will get to hemispherical part. So many more guava. Actually, guava is not exactly in hemispherical shape, but almost we can assume it. And when we halve it, we'll get to half piece of onion. Sorry, to half piece of guava is in the shape of hemisphere. Yeah. So you can see in the building dome. Dome. In SHT you have read about the Mughal architecture. Dome. The word dome. The interior of the dome is hemisphere. Taj Mahal. All of you have seen the Taj Mahal in picture. From the outside, the the shape of the dome is like this. But when you see this dome from the inside, you will see the shape is a hemispherical. The shape is hemispherical. Hollow hemispherical, you can see. Similarly, for us, globe is hemispherical, not in hemispherical shape, it is spherical shape. Globe is example of spherical shape. Okay. Now, cricket ball, a plastic ball, when we play and it broke out. So always, not always, but many times the ball will break from the middle, and we get two equal parts of ball. That is also the example of hollow hemisphere. Okay. So I just want to recall you the all examples of hemisphere. So now coming to the topic, hemisphere as we know half of sphere. So volume, for volume, for finding the volume, its volume will be the half of the volume of sphere. So what is the volume of sphere? Half of volume of sphere. Hemisphere's part will be derived from directly the part of sphere. So volume of sphere is, but half of volume of sphere is 4 by 3 pi r cube, where r is the radius of hemisphere. 2 cancels 4, you'll get 2 by 3 pi r cube. 2 by 3 pi r cube. This is the volume of hemisphere. Here 2 by 3 pi r cube. 4 by 3 pi r cube is the volume of sphere. 2 by 3 pi r cube will be the volume of hemisphere. Okay? Now, curved surface area and surface area. Now I'm asking you, please tell me, a hemisphere has curved surface area and total surface area. Hemisphere has curved surface area or not? My question is better. Hemisphere has curved surface area or not? Ravish Kumar has said yes. I just want many more replies. Three, four friend has written yes. They have replied as yes. So tell me, if the hemisphere has top or bottom surface, then definitely it will have a curved surface area. So in case of hemisphere, tell me, this is the actual figure of hemisphere. This is the right figure of hemisphere. This is the reverse of hemisphere. This is actual figure of hemisphere. Now tell me the top surface of hemisphere is. This is solid hemisphere, meaning completely filled. Solid hemisphere. Ball is the example of hollow hemisphere. Cutted onion, cutted tomato, half orange, all are the examples of solid hemisphere. So this is solid hemisphere. Now tell me what is the top surface here? Will tell me what is the top surface of hemisphere? Again, don't make my teaching monotonous. Please reply. Kamaljeet replied as circle. Okay. I just want many more reply. What will be the top surface of a hemisphere? Solid hemisphere, solid hemisphere. Mostly two students reply, Kamaljeet and Kushi. Please, other students, what are you waiting for? I'm not teaching only. I'm not teaching only to Kamaljeet and Kushi. I'm teaching all of you. So I just want all of you to reply. Top surface is circle. Okay. Top surface of a hemisphere is circle. Now, what will be the bottom surface of this hemisphere? What will be the bottom surface of this hemisphere? What will be the bottom surface of this hemisphere? What is the bottom surface of this hemisphere? Tell me what is the bottom, what is the lowest part of this hemisphere? Assume correctly and reply me. What will be the lowest surface of this hemisphere? The lowest part, you can say, what will be the lowest part of this hemisphere? No one has replied me. In the case of sphere, I told you what are the lowest and what are the topmost part of the sphere. Similarly, now tell me what is the lowest part of this hemisphere? Yes, Raj Singh. Ravish Kumar has replied point, correct. The lowest part of the hemisphere is point. The lowest part of the hemisphere is point. It means bay does not have any area. Here bay does not have any area. So here we have upper part at least. So this figure has curved surface area. And this figure has the concept of curved surface area and total surface area. Because here upper part or top part is present. So curved surface of hemisphere. CSA of hemisphere. CSA of hemisphere. How can we find the formula of CSA of hemisphere? Okay. Now, what is the surface area of a sphere? Surface area of a sphere is this portion. Surface area of a sphere is this portion. And curved surface area of a hemisphere is exactly half portion. This is the surface area of a sphere. This. And the curved surface area of a hemisphere is exactly half of this. Here, this portion, assume, but in the subject mathematics, everyone have to assume and assume correctly. This surface of the sphere is surface area. This is the surface area of sphere, and exactly half of this is curved surface area of this portion makes the curved surface area of hemisphere. So the complete 4 pi r square, so half will be 2 pi r square. Complete surface area is 4 pi r square, so the half of surface area will be 2 pi r square. So the curved surface area of hemisphere is 2 pi r square. Clear? So curved surface area is 2 pi r square. Clear? Now, I hope you all have understood how 2 pi r square has come. The complete surface is 4 pi r square and half surface, which makes the curved surface area of hemisphere, will be 2 pi r square. Now, total surface area. Total surface area. Total surface area. Total surface area is CSA plus top area plus base area. This becomes total surface area. Curved surface area plus top area plus base area. Curved surface area is 2 pi r square. Top is a circular region, so its area will be pi r square. Pi r square. 2 pi r square plus 2 pi r square plus pi r square. Okay. And what is the base area? Base area is a point, so its area is 0, nothing. Its area is nothing. Clear? Curved surface area 2 pi r square. Top portion is circle, so area of circle pi r square. Base area here absent. So in the case of base area, we will write 0. So what is the total surface area of hemisphere? 2 pi r square plus pi r square. 2 pi r square plus pi r square will give you, actually pi r square means 1 pi r square. It will give you 3 pi r square. 3 pi r square. 2 pi r square plus pi r square is equal to 3 pi r square. So curved surface area of hemisphere is, the total surface area of hemisphere is 3 pi r square. Total surface area is always greater than curved surface area. Curved surface area is 2 pi r square. So total surface area will be greater than this. That is 3 pi r square. Okay. Now one topic is left. Height of the hemisphere. Height of the hemisphere. Now tell me, what will be the height of hemisphere? Height of hemisphere. Now, reply me. According to you, what will be the height of hemisphere? According to you, what will be the height of hemisphere? Just compare with the sphere. Height of the hemisphere. Please reply. Height of the hemisphere. Again, the same thing happens. Only 2 or 3 students are participating, and don't know why others are sleeping. So many students are shown to be online, but only few are replying. Height of the hemisphere. height of the hemisphere is its radius. ये हाइट है ये इक्वल होगी उसकी रेडियस के. सो हाइट ऑफ द हेमिस्फीयर इज इट्स रेडियस. यू कैन से हाइट ऑफ द हेमिस्फीयर इज रेडियस r. Okay, so now all the 3D shapes, almost all the 3D shapes formula have been derived. Now in the 10th class, in the 9th class, partially one figures, whether it is its area or volume have been asked, but in the 10th class, the combination of the figures, area and volume has been required. Clear? In the 10th standard, you are not given only a single shape. You have been given the combination of shape, and for that you have to find out the area of combination of shapes, or you have to find out the volume of combination of figures. Okay. Now again next topic. What happens when you finish the chapter surface area and volume? You may puzzle this. You confuse the formula of area with the formula of volume. So how is the easy way? What is the easy way through which we can recognize what exactly will be the formula of area? What will be the area of volume? So what will be the formula of volume? Because there is confusion between the formulas of area and volume. So what are the ways through which we can easily recognize that this particular formula is of area and this particular formula is of volume, so that we may do not commit any mistake. So here I will like to tell you how we recognize what will be the area of, what will be the formula of area and what is the formula of volume. Now, area and volume, and our topic is surface area and volume. So here I just want to discuss the difference between area and volume and their formula. Now area. I will look here carefully at volume. I told you area. Area can be found out of 2D figure as well as 3D figure. Which means for area we have required two dimensions, two edges, or you can have two sides. For finding the area, we require two edges, you can say two sides. Clear? For finding area, we require two edges of two sides, two dimensions, you can say. For finding volume, volume is found only of 3D figures. Clear? Volume can be found out only in 3D figures. You never found the volume of a circle. You can never find the volume of a triangle. You never can find the volume of a polygon, because all are 2D figures. For finding the volume, you need three edges. You can say three sides or three dimensions. For finding the volume, you need three edges, three sides, three dimensions. Because volume can be found out only 3D figures. Because 3D figures can cover the space. 2D figure can cover only surface, but 3D figure can cover the space. and space gives you volume. Okay, and surface gives you area. So this is the basic condition of area and volume. Now let's have the examples. Suppose take the example of 3D figure. Cube. Cube. Area of cube. Suppose total surface area है. Cube. Cube का total surface area 6 into side square. Side square. 6 into side square. And volume of cube side into side into side. Here you can see clearly two sides have been used. Side square, side into side. For finding the area, only two edges, two sides are used. Here for finding the volume, side into side into side, three edges have been used. That's why this is the formula of volume. Now next for cylinder. You take a cylinder. Suppose I took the example of curved surface area of cylinder. 2 pi r h. This is the formula of cylinder. And volume pi r square h. Now generally students confused. They know 2 pi r h and pi r square. They confuse with it. For area they write pi r square h, and for volume they write 2 pi r h. 2 pi r h. So I would have to tell you 2 pi is a constant. Again pi is constant here. Here 2 pi, here pi is constant. Now r is 1 h. H is another h. So here two edges are used. H is not always length, breadth and height. Clear? So you can say side or dimension. The part. First side you can say the first edge is radius here, second edge is height. So here two edges are used. That's why this is the formula of area of cylinder. Now look at here. Here three edges are used. Pi constant, r square means r into h. Pi constant. I have expect r square. Now then clearly see three edges are used. First edge, second edge, third. Here first edges are same, but in counting they are two. First edge, second edge, third edge. Which means three edges are used here. That's why this is the formula of volume. First edge R, second edge also R, and third edge is H. So this is the formula of volume. Clear? Now, let's first cone. CHF cone pi r l. Pi r l. That volume 1/3 pi square h. Now, pi is again constant. Here 1/3 pi is constant. Here pi constant. First edge is r, second edge is l. Again two edges are used. First edge r, second edge l. So again two edges are used, which means this is the formula of area. Now here you can see 1/3 has been constant, and now r square r into l. Again here three edges are used. First edge r, second edge r, third edge is l. Again three edges. 1, 2, 3. Three edges are used. So this is the formula of volume. This is the formula of volume. Here three edges are used. Now next one, sphere. What is the formula of surface area of sphere 4 pi r square. 4 pi r square. Again 4 pi constant. R square converted to r into r. 4 pi constant r into r. Again two edges are used. Here both edges are same, but in counting two edges. First edge r, second edge r. So the formula is for area. Now, what is the formula of area? So what is the formula of volume of sphere? 4 by 3 pi r cube. 4 by 3 pi r cube. Again 4 by 3 pi is constant. 4 by 3 pi is constant. Now three edges. First edge is r, second edge is r, and third edge is also r. First edge, second edge, third. Again here three edges are used. First edge, though all three edges are same, radius. But in counting there are three. That's why this is the formula of volume of sphere. Clear? So after this, I was sure that no one will make mistake in the formula of area and volume, because for area you need only two edges, and for volume you need three edges. So don't be confused with the formulas of area and volume. Clear? Now I hope you can easily differentiate between formula of area and formula of volume. Now one important thing I just want to discuss here. Let's have table. Table is not only used in numbers, just like 2 1 2, 3 1 3, 4 1 4. It may be used anywhere. It's up to you. How can you use the table in any field? Okay. In trigonometry, we have used the formula of tan theta, sin theta, cos theta, cosec theta, and all that. Similarly, again we are using the table here. The table is here in the case of pi r square. Pi r square means 1 pi r square. 2 pi r square. After 2 pi r square, what comes? 3 pi r square. After that, what comes? 4 pi r square. Just like the table, we will learn it. 1 pi r square, 2 pi r square, 3 pi r square, 4 pi r square. All are the formulas related to some figure. All are the formulas related to some figure. Now, it's clear that this is the formula of area because two dimensions. So two edges, both edges are r here. R square, r equal, r square, r square. In the first case, pi constant. Second case, 2 pi constant. Third case, 3 pi constant. Fourth case, 4 pi constant. So r square. This means these are the formulas of area. But whose area? What are the areas of what? Pi r square. Area. Pi r square. Area of circle. Table is, you can think table of counting. 1 pi r square, 2 pi r square, 3 pi r square, 4 pi r square. Area of circle. Now, curve circle, 2 pi r square. Recently I told you this topic. CSA of hemisphere. CSA of hemisphere. Now third, total surface area of hemisphere. Now 4 pi square, surface area of sphere. Just like counting on table, you can write. You can learn it. Pi square area of circle. Remember, 2 pi square, 3 pi square are the part of hemisphere. 2 pi square, 3 pi square are the part of area of the part of formula of hemisphere. 2 pi square is CSA of hemisphere. 3 pi square total surface area of hemisphere. Now 4 pi square surface area of hemisphere. It's very easy to learn if you make the table of these. Pi square is basically the area of circle. 2 pi square and 3 pi square are the part of hemisphere. One is CSA and another is total surface area. 4 pi square is the surface area of hemisphere. Clear? So, beta, that's all. What have been taught to you are very important while you attempt the question. Because if you know the formula correct, only then you will be able to reply exactly. If you don't know the formula, how can you reply? How can you find out the area, volume? So the basic thing, first thing you have to learn the formula. And I've taken 2 or 3 sessions only for derivation, just because all these formulas will be remembered for longer time. Because that only that learning is not efficient. If you know how the formula is come, you will remember the formula for longer time. Clear? So I hope all the formulas that have been taught to you will be remembered to you, and many more extra things have been taught to you. Please also remember that also. Okay? So exercise related to this will be adapted in WhatsApp as well. Some questions, some difficult questions which requires explanation will be discussed here. Okay? And but my only request is beta just join karo, because all the teachings only for you. Because you are board class student, you have to attend the board examination, not me. So please attend the class regularly. Okay, that's all for today's session. Hope you have understood all this. Thanks and have a better day ahead.